begin the operation of the red EMCO turning center here in our lab at Mountain Community College. First step is to turn the main power on. To do that, turn the breaker on, followed by the machine power button. The order in which we do this is extremely important because of the power conversions that take place between the European standard that's inside the machine tool and the American standard on the main power coming in. And it goes through some kind of a power converter.
Show us the main toggle again.
The main toggle is this one. It's the first one that we do, followed by the machine power. Now we notice as soon as the machine power goes on, the cooling fans for the electrical components inside the machine come on, and you can hear those running. As we come around to the front of the machine, we notice that the work light is on the inside, and we notice that the control has begun its initialization process. This error message here is telling me that the emergency stop is on. So if I turn that off, I now have an alarm telling me that the reference position is not set. That means we need to calibrate this machine tool before we do anything else. I press the clear entry button, which is CE on the control. I close the door because this machine requires that the door be cycled. I turn the hydraulics on using the auxiliary mechanisms function. What you just heard is the auxiliary hydraulics coming on. And now I have highlighted at this point on the screen the reference indicator telling me that I need to reference the machine. Notice there is nothing for the X and Z axis at this point. This machine will not run until it is referenced. So I next press the cycle start button. If you notice in the slides, the door has to be closed. First thing it did is it moved the X axis a little bit, and now it's going to, as soon as it finds the X reference position, factory preset, it puts an X value in the CRT, and now it's found the Z position. At this point, we are ready to qualify the tools. One of the differences with the EMCO turning center is that the program workpiece coordinates are set within the CNC code for the particular part that you're making. So we do not have to qualify for a particular axis position. What we do qualify for is the tool length. The steps in qualifying for the tool length are, first of all, I'm going to make sure my turret is, or my chuck is closed, and I've got a workpiece in here. I next jog my turret to an empty position, and I have 3 tools in here, so I'm going to come down to a position like that number 7 position, which gives me an empty turret position. Now using the jog buttons, I'm going to move using the manual jog buttons, and I'm going to use my override switch. I'll set it to 100% because at this point I can go pretty fast. I'm moving the turret. I move it out in Z so it clears the tailstock. My next step is to manually jog it down in X. As I get the turret down in X, now I'm going to bring it in closer to the face of the part. One thing I need to watch with this machine is I need to be very careful as I approach the workpiece and turn the feed rate that I'm moving the turret at down, because if I hit the face of the part and it's going too fast, I'll get a Z-axis servo overload, and then I have to start all over from power down back to where we are right now. At this point, what I want to do is bring the turret up to the face of the workpiece, and in order to do that, I'm going to first of all pull the control unit around so it gives me access to the controller and access to the workpiece at the same time. The other thing I'm going to do is slow the feed rate down. I've got it set at 2%, so the jog rate is going to be very slow. Now when I bring that in, I can watch the numbers upgrade on my CRT and tell that it's moving. I moved down to 1% now because I'm getting very close. I now have a slight resistance on the paper between the face of the turret and the face of the workpiece. What I need to do at this point is record the Z-axis value that shows up on the screen. So I'm going to write that down. It's a Z, in this instance it's Z 7.0014. What I've done is recorded the value on this piece of paper because I'm going to need that for qualifying the Z-axis length on my cutting tools. Now, with that done, I manually jog the turret away from the face of the workpiece. Once I get the turret away from the workpiece, I'm going to jog up in the X-axis, and the reason for doing that is I need to have a safe index position so that I can index the turret. Now that I've cleared the part, I can go ahead and press the turret index button and move it so that the number 2 tool, which is the next one in the turret, is in the cutting position. With that tool in the cutting position, we then qualify the tool for the Z-axis and the X-axis length. My steps in doing this, again, I'm going to manually jog it so that the cutting tool comes down in the X-axis, slightly below the outside diameter, and then I'm going to manually jog the Z-axis slide so it comes in almost to the workpiece. We slow it way down to 1% and begin jogging it in. Now I need to check again with my feeler gauge. I have a little bit of resistance on the turret. To qualify this tool, this is the number 2 tool. I know that because the turret tells me, or the CRT tells me that number 2 is in the cutting position. To qualify this tool, I press the Shift key, the T key, and the response I get on the CRT is it has an X and it says automatic tool offsets generate. I'm going to change that to the Z, and I'm going to enter the value that I wrote down on the piece of paper from the face of the turret. So I put in my 7.0014. Enter. I do Shift T 02, enter, and it has now, the controller has recorded the length of that tool from the face of the turret to the tip of the cutting edge, and automatically calculated the distance and entered it into the control. To qualify the X-axis for this cutting tool, my next step is to increase my speed a bit. I'm going to manually jog the turret away from the workpiece. I'm going to jog up in the X-axis so as to clear the outside diameter. I now manually jog so So the cutting tool is over that outside diameter. Next, I'm going to slow my feed rate down and begin bringing the cutting tool down to the outside diameter of the workpiece.
We're moving. It's just moving slow.
Yeah.
As it comes closer and closer, what I want to do at this point, I'm going to drop it down to 1%. Again, I use my fancy, expensive feeler gauge piece of paper. Once I get the cutting tool so I have resistance on the papers, just in a similar manner that we would do for any of the turning centers, the procedure to measure the x-axis on this machine is to press the shift key, the T key, the X comes up. I'm qualifying the x-axis, so I go ahead and accept the X, and I put in a value of 1.000 because the stock of the workpiece diameter is 1 inch diameter. I next press enter. I do a shift T 02 enter, and now it has written that value into the control. The skeptical among you may wonder, well, how does he know it put it in the control? If I press the edit key and the shift and the T, it opens the tool data register, and what I had in there previously was for tool 2 was a 0 value like you're seeing for 4, 5, 7, and 8. The 1, 3, and 5 and 6 were qualified in a previous session. Tool 2 now has a length of X 2.4754 and a Z value of negative 2.7968. Those values represent the distance from the face of the turret to the tip of the tool in the Z-axis, and from the center of the pocket that this holder is in to the tip of the tool in the X-axis. The negative sign indicates the direction.